try to make it more systematic. And so for the Gauss problem, basically is this. We are given informations, and let me do these things here. So here is, for example, is our focus. And we are given the two R1 and R2. We know the two positions, and the R1 can be initial positions, R2 can be the destinations we want to intercept. And also we are given the, say, time of flight from the position 1 to position 2. Let me call the R1 pointing to a position A, and let me R2 point to, say, point B, from A to B. Okay, and then here we want to find out is the direction, the velocities here. And also here we know we want to find the, so these are 1, 2, 3. And also we want to know the way of flight. The way of flight, and that definition is we did last time. And for example, here we have the R1 and R2. So for example, the R1 and R2, if they constitute with an orbit like this, and then here if we take this route, okay, because this anomaly between the R1 and R2 is less than pi. So here is we call the short way. On the other side, if we are given the R1 and R2, and if it constitutes an orbit like portion like this, if it would take this way, then that means here this true anomaly is greater than pi. In this way, we take in this is the condition the wrong way. And you need to define which way you're going to try in. So here is a way of this, the flight, long way or short way. And then here we're going to find is the corresponding, so say here, so if we have finding the connecting orbit, basically transfer from R1 to R2, we're going to calculate is what is V1 and what is V2. So this is the statement of the Gauss problems. Okay, and for the statement of the Gauss problems, and basically here the focus is you will have to find out what is the transfer orbit, and from here to here, and then calculate the V1, V2. So here we can have the revisit what we have done in the previous chapters. Here I list the equations we have, and hopefully from these equations we can have certain clue to waiting for how to solve the problems. And using the linear combinations concept, using the 4 parameters f dot, g dot, and from the previous chapters we have these equations. Basically what we have done in chapter 4, we ended up is this. We have calculated R1 and V1. Then we can convert the R2 basically equal to F plus G, and R1 plus V1, and V2 equal to F dot plus G dot. And that is using the concept, the linear combination of any two non-collinear vectors, and we can always express them in for other vectors. So based on this, we have this expression here. So our answers to the Gauss problems is on these two equations. So we're looking for is this, we're given the R1, R2, delta T, etc. Our answer, basically, final form will be on this. Okay, so that means basically for this kind of Gauss problems, if we can, based upon the given information, we know the four parameters f dot, g dot, then we can right away have our solutions. Okay. And so right now, before we speaking of the why we have to study the Gauss problems, and which means the application, let us talk about the solution procedures first. And then once we're familiar with a few examples, we can talk about the applications. So for this case, this is the one. And here we list out is the f, the four combination coefficients, which means given in this form. And in the previous chapters, we have the handout, and that summarized. Either we can express those coefficients in terms of the delta nu, and that is true anomaly, or we can express it into eccentric anomaly, or we can express it in terms of universal variables. Okay, so please refer to that handout. We have quite a few forms for those things. And right now, I list is only f expressed in terms of delta mu and also in terms of delta e. From here, I want to, with this one, I want to give the general thinking what would be the most efficient numerically, the most numerically efficient way to solve the problems. Okay, so that is the goal here. So right now, looking at these equations, and so again, I will keep this map here, and we're looking at how many variables we have. So we can count from the first line equations here. So we have R2, and we have P, and we have delta nu, and we have A, and we have R1, and E, we've been delta E. Okay. So for this one, we have P appear here, and we have delta nu, and etc. So basically, from here we only have 1, 2, 3, 4, 5, 6, and we lacking 1 and T. From if we keep writing, so P delta mu R1, R2, and then A. So here we have T. Okay. So basically, T is the time of flight. Okay, and basically time of flight is the, that is corresponding to from one destination to the other one. So here we have the 7 variables. And let me rewrite this one. So let me put into a better arrangement. So R1 and R2 and delta nu and T and P and A delta E. Okay, so let me rewrite the 7 variables into this. And now we can check into how many we are given, we know. And so for this case, the one is we know the R1. So basically these variables are given. And R2, that is given from our informations. And also we know the time of flight. So basically sometimes we call the time of flight using delta T or T. Depends on the situations, and don't get confused, okay? And how about nu? So here, this is our delta nu here. Are we able to calculate delta nu? How do we know that one? So I would say this one is also given. How could we know that is given? How to calculate that one? And you can see if this is the R1 vectors, another vectors R2. So let me draw it in this way. Okay, so this is our delta nu. So you see R1 dot R2 per our fundamental, that's the inner product here. So that is R1 R2 times cosine delta nu. So from these simple operations, we can determine data nu. So basic data nu is given. Okay. So under these situations, then we can only, you see we have 7 variables, and then right now we have 4 given informations. We're looking for 3 unknowns. And from here, you're looking into this equation here, and we have 4 equations. But here, the 4 equations, they are independent. They are dependent. So basically, from the 4 listed 4, we have only 3 independent equations. So in theory, 3 independent equations and 3 variables, in theory, we should be able to solve for this one. And now the issue is how to do this one, how to do this kind of things. And the way is this. So here, let me say, in this one, we have 3 unknown. Okay, so from the 4 equations here, we have 3 independent equations. So basically, 3 variables, 3 equations. We can solve for this one. And let me say, 3 equations is f dot, and g. Okay. So the last one, I treat last one as the dependent. I don't use it. So we have 3 equations. So now this procedure is this. Look at the 2 equations here. The f function and f dot functions. The involving here is everything is R2P, delta V, etc. But f and f dot, they don't involve, specifically, they don't involve time of flight. Okay, so, and the time of flight only involved in G. Good? Okay, so that means here we kind of thinking is this. We want to find out the general solutions, procedures. Is this. From f and f dot equations to solve for the necessary P, A, and delta E, and once we solve the PA delta E, then step 2 is to calculate the time of flight T. From equations G, okay? Then we compare. And let me call the time of flight is Tn. Our T and function Tn, n means for our iterated index. So compare Tn to the given delta T. Then if they compare and if they Tn minus the given delta T is less than the tolerance, then stop. We got the answers, solutions. If not, then basically here we continue to improve. We solve for another set of the 3, and then we go to check the corresponding T, and then we'll continue. If not, then improve the calculations in step 1. Okay, so that come up with a loop. So that is the general considerations for our solution process. And so basically here I would say right now we're looking for is using the three equations, 1, 2, 3. And among the three equations, we have three unknowns variables we're looking for to solve. And what would be the good way to solve for? And here, for this case, the function g is going to calculate the time of flight. And the time of flight is going to check against. So basically, this one is our calculating step 3, not used in step 1. So right now, in terms of step 1, we only have two equations to use. And in step 1, we have two equations, f and g, in step 1, we have f function and f dot functions. Using the two functions, we need to come up with three numbers. The three numbers, one we come up with, we're going to use to calculate t. Hopefully, the three numbers we obtained from step 1 is the right one. That will give us the right time of flight. Hopefully, right? So right now to this step, you can see right now we are come to a guess. See if we can guess a good combination of the three unknowns, and that both fit into the two equations, and then give us the right number for t. Okay, so basically right now in step 1, we want to come up with how to make a good guess is this one. We have three unknowns, and here we have only two equations. So we need to make one guess. We need to make one guess from the three unknowns. We need to guess one, and then using the two equations, we solve for the other two. Got it? So right now this is thinking, and we are now in step 1. Okay, so now we need to guess one and solve for the other two based upon the two equations. Then there's a lot of the combinations. We might guess, say, let me make it the worst case. So say, let me make one example. So if I would guess A, we'll see what happens. So if we would guess A, and so let me highlight the unknowns here. So if we guess A, then the unknown is P and delta E. So let me highlight the positions of P and delta E. You just watch, and you don't need to make any mark until I tell you so. So right now the delta E is here. So if I say the first one is guess A, then P and delta E are the unknowns here. So let me highlight. So this is 1 here. And anything else? So here is P. Okay, so here if we would guess A, then the two unknowns appear in these positions. This one seems okay. This one in square root is not that complicated in terms of the solutions. But this one, this unknown is appear in the cosine trigonometry. That makes the whole thing it's no good. Everything involved in arc cosine or something, that makes things so complicated. We wish is everything involved is kind of the polynomial-like. Okay, so making the guess on A is not good. So from this kind of the thinking, we would say if we could guess delta E, then we see what happens. If we would guess delta E, then our unknowns would be here. A is here, and everything. So A is here. So if we would guess delta E, then our two unknowns A, P, that appear like this. So seems like the two equations basically become is kind of polynomial-like equation. It's easier, right? And from this kind of combination here, we should be able to solve for it. Say using the, I would say, for example, here I can say, I would say express A in terms of P using the first equation, then plug into the second equation, then I combine only one equation, then I can trace the point. On Excel spreadsheet, using the spreadsheet in Excel, I can make a column and make many points of the P, and then I can draw the curve, and then I can find the roots very easily. Okay, so since this is a good strategy, so here I would say in the step 1, basically here is this, we guess a value for delta E, then from F and F dot equations to solve for P and A. So at this end, then we have P, A, delta E values available. Then we can go to step 2 to determine the time of flight. Then we compare. So what happened, if we are so lucky we get the right one, then we'll stop here. If not, then how can we improve? If not improve the calculated in step 1, that means we need to improve our guess. Got it? Okay, so what happens if usually it's come to here. If not making this one satisfied, then you have to improve your guess, and then we go to the second one. And how to improve guess, and then probably we can put into, say, using, try to come up with a good formulation. So for running the Newton's method, or maybe you can apply whatever the numerical approach you learned before, say dissections method, or they call the secant searching method, that whatever that you can try to apply here, that is to make the things a good, better guess. Okay? So is there anyone clear about our thinking logic, right? So that is the way here. And so done. Stop.